Okay, this is the overview of what I've got as a test setup. What we have is the what I call a barber pole quantum motor running, and I'm picking up the pulses from a magnetic reed switch at the top plate being fed to channel A on my oscilloscope, which is the upper trace, and the lower trace is the analog output of the balance beam itself from the outer arm being picked up and fed to an analog DC amplifier. And you have a constant current, constant voltage power supply at the left with a digital readout, developing about 1.9 volts across the entire setup, including the mercury, at 4.96 amps. And to give you an idea of how this thing is stabilized, because it is very sensitive, on the back where you couldn't see it is a copper sheet in between two very powerful magnets. The lighting is not that good here, but you can see the two magnets there, and what that copper sheet does is it acts as an impediment towards any vibration. There's the pickup. There's two diodes in there, one above the other, and the black surface on the balance beam is a shadower so as not to pick up too much extraneous light from the outside. And there's an infrared diode transmit on the left over to two diodes on the right. Okay, the two little bug arts there are, on the right is a DC analog amplifier, and on the left is a wave shaper to help eliminate the pulses, extraneous pulses from the magnetic reed switches, which are not really clean when they switch. So that's the overall setup. Again, today is January the 10th, 2018. End of demonstration. Okay, of interest here is that the analog trace, as you see it there, is, if you look at the center line, you see the arrow on the left, the yellow arrow. 1 centimeter down from that, or one graticule line, is 0, and the next line down is 500 millivolts offset, which represents 0. Okay, now as I allow the motor to begin spinning, you're going to see the sine wave drop down in overall level from what is referenced as 0 down to 500 or 400 millivolts right now, below 0 in a negative direction. In other words, the offset set as 0 below the center line, so the sine wave is running between a little bit above 0 to a little over 500 millivolts negative. So there's a level shift, a DC level shift. Now I'm getting a sine wave modulation, maybe from the offset of the balance beam. As the balance beam spins, as the motor spins on the balance beam, there may be a vibration introduced due to the fact that the horizontal is not perfectly balanced. But the important thing here is there is definitely a vertical offset of a DC fashion in a negative direction, which means, as the way this thing is calibrated, it's being pulled down. It's being pulled down, shifting in a negative direction. Now, I'm going to go ahead and allow this thing to come to rest. And you see it beginning to settle at 1 graticule division below scope 0. My offset is 500 millivolts in a negative direction, which is actually 0, to separate it from the upper trace. I didn't want one trace laying right over the top of the other trace, so I offset them. Top trace is calibrated in volts at 5 volts per division, and it's offset 5 volts up from the center. The bottom trace is at 500 millivolts per division and offset 500 millivolts down, which is 1 graticule division from 0, which is actually my electronic 0 on the balance beam.